Ever wondered how on earth can aircraft carriers withstand the enormous stormy weathers and hit the oceans every now and then? I mean, imagine one day if the Gerald R. Ford carrier got flooded and sank underwater. That would be a $13 billion loss right there. That's a very big risk that navies take, considering the fact that hundreds of civilian boats and ships lose the battle against the waves every year. So what makes the engineering of an aircraft carrier so special? And why won't monster waves flood their flight decks anytime soon? Let's find out. Before we start talking about the superiority in the engineering and the designing of aircraft carriers, let's just define what monster waves are first. Monster waves, or what many experts call them as rogue waves, are unusually large and unpredictable surface waves. They're this type of ocean wave that travels along the boundary between the ocean and the atmosphere, often caused by wind or seismic activity that can be extremely dangerous to ships and isolated structures such as lighthouses. One example of a ship being enveloped by these killer waves is the MV Derbyshire, a British ore bulk oil combination tanker that disappeared amidst extreme weather conditions and the monstrosity of the waves that damaged it pretty hard in the South China Sea during Typhoon Orchid in 1980. What makes these waves powerful and dangerous is that they can be expected to reach at least 20 meters, that's 66 feet or more in height, which is pretty insane. They can also reach extraordinary heights, sometimes towering over 80 feet, that's 24 meters and even more. Rogue waves do not appear to have a single distinct cause. They're usually believed to be caused by a variety of factors. One primary cause is the constructive interference of smaller waves, which can amplify their height when they align in phase. Additionally, extreme weather conditions such as hurricanes, typhoons, or intense storms can generate powerful winds and currents that contribute to the formation of monster waves. Other factors include ocean currents, underwater topography, and interactions between different wave systems, all of which can combine to produce these towering and unpredictable phenomena. So how can flight decks of aircraft carriers remain untouched? Well, in order to answer that, let's take a closer look at the incredible design of these vessels and how they survive the harshest conditions of ocean climates. Aircraft carriers stand as formidable symbols of naval power. Their design is meticulously crafted to navigate the world's oceans with unparalleled resilience. I mean, take a look at these humongous beasts. They're at the pinnacle of what humans are capable of building. These massive vessels are not merely floating platforms for aircraft operations, but are engineering marvels optimized for survivability in the harshest of maritime environments. At the core of their design philosophy lies an emphasis on withstanding the relentless assault of rough seas and adverse weather conditions. Every aircraft carrier is carefully designed with a critical dimension that pretty much defines the vertical distance from the waterline to the main deck level, which is the freeboard. The big gap from the water to the deck level is important because it safeguards the carrier against the onslaught of waves, particularly during inclement weather or high sea states. Using this design, naval engineers make sure that aircraft carriers present towering barriers that impede the ingress of seawater onto their flight decks. In the Battle of the Oceans, this architectural feature serves as a first line of defense, shielding vital aircraft, equipment, and personnel from the ravages of the sea. As waves crest and crash against the hull, the elevated main deck stands as a bastion against inundation. Speaking of the hull, aircraft carriers are equipped with crazy engineered hull designs that aim to safeguard the flight deck from monster waves. The hull of these big vessels are made up of extremely strong steel plates measuring several inches thick. This heavy body is highly effective protection against the harshness of the oceans. The hull portion below the waterline is rounded and relatively narrow, while the section above water flares out to form the wide flight deck space. And if you notice, the shape of the hull on some aircraft carriers can be interpreted as a V-shape. This V-shape has the purpose of increasing vehicle and crew survivability by deflecting an upward directed blast from a landmine or improvised explosive device, and also decreasing the chances of flooding caused by big waves. The deck of an aircraft carrier is in an angled shape. The effectiveness of the angled deck design lies in its ability to harness the forces of nature to the ship's advantage. Instead of allowing water to pool or collect on the flight deck, which could compromise the safety of personnel and equipment, the angled deck facilitates the rapid runoff of water, keeping the deck dry and functional even in challenging maritime conditions. This feature is particularly crucial during stormy weather, when waves and seawater spray pose a constant threat to the integrity of the ship's operations. By redirecting water away from the deck, the angle design minimizes the likelihood of hazardous conditions that could impede flight operations and jeopardize the mission readiness of the carrier. Moreover, this design is the result of all the planning and engineering expertise that goes into the construction of modern aircraft carriers. If you haven't been on an aircraft carrier before, did you know that the flight deck contains a network filled with drains and gutters? Yes, this drainage system comes in handy during storms, and it helps the flight deck survive against flooding. These drainage mechanisms are strategically integrated into the deck's layout. They are built to ensure the efficient removal of water accumulating from rain and, most importantly, the monster waves. Gutters have the purpose of channeling water toward the drains and away from critical operational areas such as aircraft launch and recovery zones. The selection of seawater-resistant materials is paramount in the construction of aircraft carriers, ensuring their longevity and operational effectiveness in maritime environments. These materials undergo rigorous scrutiny to withstand the corrosive effect of monster waves, a constant threat to the structural integrity of the ship. By employing alloys, coating, and composite materials specifically engineered for their resistance to corrosion, aircraft carriers can mitigate the risk of leaks and maintain their structural integrity over extended periods of service. This proactive approach not only enhances the durability of the ship, but also minimizes the need for frequent maintenance and repairs, thereby reducing downtime and optimizing operational readiness. Seawater-resistant materials are another component that contributes to the overall safety of the vessel by preventing catastrophic failures that could compromise mission success or endanger the lives of personnel. Another safety feature that aircraft carriers have is the safety netting system. Safety netting serves as a multifaceted safeguard, bolstering both safety protocols and operational efficiency amidst challenging maritime conditions. These nets are strategically positioned across the flight deck, constituting a resilient defense against the threat of flooding during adverse sea states. Composed of high-strength materials such as steel cables or synthetic fibers, the netting forms a robust yet very flexible barrier capable of withstanding the onslaught of heavy seas and turbulent winds. Safety netting systems deflect incoming waves away from vulnerable areas. They curb the risk of flooding and safeguarding aircraft equipment and personnel from harm. They also serve as a crucial component in aircraft arrestment procedures during landing operations. In the event of an aircraft overshooting the arresting gear or encountering a landing mishap, the nets provide a secondary means of halting the aircraft's momentum, averting potential disaster. Modern safety netting systems undergo rigorous testing and certification processes to ensure optimal performance in challenging maritime environments. They are integrated seamlessly into the aircraft carrier's design and layout to enhance overall effectiveness while minimizing interference with flight deck operations. What also makes aircraft carriers unique in their designs is the incredible stability that they have. Ensuring the stability of the vessel, even under dangerous and unpredictable situations, is the most important factor in the blueprint of the design. Carriers have a low center of gravity, which is a fundamental characteristic that enhances their resistance to rolling motions, particularly in turbulent seas. Stabilization systems include ballast tanks and active stabilizers. Ballast tanks enable precise adjustment of the ship's weight distribution, optimizing stability under dynamic conditions. Meanwhile, active stabilizers further augment this resilience by dynamically counteracting the forces of wave motion, effectively dampening any tendencies for excessive rolling. Modern aircraft carriers prioritize proactive measures to navigate safely through potentially hazardous weather conditions, leveraging cutting-edge weather forecasting technology to inform their operational decisions. How so? Basically, by carefully monitoring and following sophisticated meteorological data and predictive modeling. These carriers can accurately anticipate the onset of severe weather phenomena, including the emergence of rogue waves in specific oceanic regions. Armed with these insights, naval commanders can strategically chart their course, steering clear of areas identified as high-risk zones for rogue wave formation. This preemptive strategy not only minimizes the likelihood of encountering these formidable natural phenomena, but also enhances overall operational safety and efficiency. And of course, we cannot forget that emergency procedures are a cornerstone of aircraft carrier operations, as they provide a structured response to reduce the risks posed by flooding incidents. When faced with the threat of flooding, carrier personnel rely on a well-coordinated set of protocols to swiftly contain and resolve the situation. One critical aspect of these procedures is the deployment of damage control teams, who are highly trained personnel tasked with assessing and responding to emergencies. These teams are equipped with specialized tools and equipment designed to seal off breached compartments and pump out any water that has infiltrated the ship. For example, they may utilize portable pumps and inflatable seals to isolate affected areas and prevent the spread of flooding throughout the vessel. Additionally, damage control teams employ sophisticated monitoring systems to assess the extent of the damage and prioritize response efforts accordingly. Emergency procedures extend beyond immediate response measures to encompass comprehensive training and drills conducted regularly to ensure readiness and proficiency. Through simulated scenarios and hands-on exercises, personnel are familiarized with emergency protocols and equipped with skills necessary to respond decisively in high-pressure situations. This commitment to preparedness underscores the Navy's dedication to safeguarding the safety of personnel and preserving the operational effectiveness of its fleet. In essence, all of what we talked about combined served as a vital lifeline in times of crisis, enabling aircraft carriers to navigate through adversity and emerge stronger and more resilient than before. Navies implement what has been learned from past experiences and incidents to improve modern and future designs when building aircraft carriers. We can take a look at some examples where an aircraft carrier flight deck was flooded and how the Navy responded to such an incident. In 1969, the USS Enterprise, the CVN-65, a symbol of American naval prowess and technological innovation at the time, found herself facing a formidable challenge while undergoing routine maintenance at the Puget Sound Naval Shipyard. This iconic nuclear-powered aircraft carrier, renowned for its size, capability, and pioneering propulsion system, encountered a serious flooding incident that threatened to compromise its operational readiness and integrity. At the heart of this emergency was a critical failure within the carrier's intricate nuclear propulsion system, a malfunctioning valve that betrayed its duty, allowing a relentless deluge of seawater to breach the ship's defenses and inundate multiple compartments, including the revered flight deck. The consequences of this breach were immediate and profound, plunging the USS Enterprise into a state of crisis that demanded swift and decisive action from its crew and support personnel. The flooding unleashed by the malfunctioning valve built some serious chaos within the confines of the carrier's formidable hull. The corrosive embrace of seawater permeated the once secure compartments that threatened the structural integrity of the vessel and imperiled the safety of its crew. The flight deck that was typically a bustling hive of activity became a battleground against the relentless advance of water, as crew members scrambled to contain the breach and mitigate its consequences. The inundation of critical areas not only disrupted ongoing maintenance efforts, but also posed significant logistical challenges, as personnel worked tirelessly to stem the tide and prevent further damage to vital systems and equipment. As news of the flooding spread, the USS Enterprise became the focal point of a frenzied rescue and recovery operation, drawing upon the expertise and resources of the Puget Sound Naval Shipyard and naval personnel from across the region. Damage control teams, composed of skilled and experienced professionals, mobilized with purpose and determination, racing against the clock to assess the extent of the flooding and implement measures to staunch its flow. Their efforts were bolstered by the unwavering resolve of the carrier's crew, who rallied together in the face of adversity, united by a shared commitment to safeguarding their ship and preserving its legacy of service. The road to recovery was fraught with challenges and obstacles as repair crews labored tirelessly to repair the damage inflicted by the flooding. Extensive repairs were required to restore the carrier's compromised compartments and systems to operational status, a daunting task that demanded precision, expertise, and unwavering dedication. Welders, electricians, and engineers toiled around the clock. Their efforts fueled by a sense of duty and steadfast determination to see the USS Enterprise rise from the depths of adversity and reclaim its rightful place among the ranks of the world's most formidable naval vessels. In the aftermath of the flooding incident, the USS Enterprise emerged battered but unbowed. The ordeal served as a sobering reminder of the inherent risks and challenges associated with naval operations, particularly those involving complex and sophisticated propulsion systems. Yet it also underscored the unwavering commitment of the United States Navy to maintain the readiness and effectiveness of its fleet, ensuring that its ships remain at the forefront of global maritime power projection. As the USS Enterprise returned to active duty, her hull restored and her spirit unbroken, she served as a shining example of the Navy's indomitable spirit and unwavering dedication to excellence. The lessons learned from the flooding incident would resonate throughout the naval community, driving improvements in safety procedures, maintenance protocols, and emergency response capabilities. Monster waves, though rare, pose significant dangers to maritime vessels due to their immense size and unpredictability. These rogue waves can cause havoc on ships caught in their path, causing structural damage, flooding, and even capsizing. However, modern aircraft carriers are designed and equipped to withstand extreme conditions, including monster waves. With reinforced hulls, advanced stabilization systems, and stringent safety protocols, these vessels can navigate rough seas with relative confidence. While the threat of monster waves remains a concern for maritime operations, the rarity of such events and the resilience of modern carriers mitigate the risk of catastrophic flooding. We hope you found this video helpful and entertaining. Thank you all for watching. Please leave a like, subscribe to the channel, and comment any thoughts you have on the topic in the comment section below.